Hi team, this is session 5 in Linux Essential series, File Management Commands in Linux. I will be using demonstration plus discussion, and you will find few topics common from the previous session, like a relative path, absolute path, which I demonstrated in the previous session. So you will find this session quite easy, because now you will find some overlapping topics because of the relevance to the previous topics covered, so you will find it comparatively easier now to understand the whole concept. So the agenda of the session is file system, that is files, directories and file names, the file name rules, path names, absolute and relative path names, the inode, link command ln, hard link and soft links, the more command, the word count, the history command and the file command. So these are the commands. So some of the concepts and some of the commands will be discussed in the session. File system. Linux provides a hierarchical or tree-like file system. A tree, inverted tree. When you invert a tree, what you see on the top is root. It supports two main objects, files and directory files or simply directories. Remember one punchline, thumb rule about Linux is that everything can be reduced to a file. Even the processes are files, devices are files, terminals are files, printers are files, files are files, directories are files. Everything in Linux is a file. But in RHEL7, this is slightly different now. Everything is a unit. So unit may be in terms of hierarchy. So we'll discuss that part. Unit is slightly different from file. Everything can be taken out. Think of it as a, we can think of everything as of a unit. But file is the right word to understand as a beginner. From Unix point of view, there is no difference between the two. That is files and directory. There is no difference. Why? Because both of them are actually they are files only. From the user's point of view, files are data that you want to store, that you want to manage. And the content, and the directories are containers of the files. In the form of tree, if I want, I can explain that a tree, on a tree, the leaves are the data or the files, and the branches are the directories or the containers. So branches contain leaves, so branches contains, directories contains files. Another thing, the comparative here, we can have branches on another branches, sub branches concept on a tree. But we cannot have branches on leaves, whereas we can always have leaves on branches, which means here with respect to this Linux I'm saying we can have files in directories, but we cannot have directories in files. So from the user point of view, this statement was from the user point of view. From Unix point of view, both are same. In reality, files are simply stream of bytes. So when the flow of bytes, flow of text is happening, that stream is basically flow. So stream of bytes is basically, you can call it as file. Critical design philosophy of Unix is the file. That's the most important thing. Initially it was stream which was developed. And these are the concept of how the files and directories are organized, that is inverted tree. So what we have is a directory. Under directory we can have files and we can have other subdirectories. So this is a directory. This is, let's say, root directory. Under that we can have another directory, one more directory, one more directory. Under this directory we can have files, ordinary file. We can have another ordinary file. We can have a directory also. Under this directory we can have another subdirectory, and we can have files also. And under the directory we have ordinary file. So we can have ordinary file under any directory, and we can have another directory under any directory. So this tree can grow to a huge size depending on the number of files we have. So generally we have many layers or many levels of directories and files. That's how they are organized. So in other words, if I say what is the location of this file, this file is under this directory is under this directory, and this is under this directory, and this is under this directory. So this is the complete path of the directory, starting from here, all the way from here to here, and then from here to here, and from here to here. So this is the complete path of the absolute path of this file. So this is the concept of files and directories, how they are organized. File names. Every file has a file name. Current version of Unix support up to 255 characters. Older version limits to 14 characters in the file name. Almost any character can be used in a file name, but sticking to some limited character set like uppercase A to Z, lowercase a to z, comma, 0 to 9 digits, and dash, that is hyphen, and underscore will be good for us. Though we cannot use period in the file name, and dot can be used as any other character, but it may denote special files also. Like if a file starts with dot, that means the file is hidden, or it will not be listed or displayed with normal ls command or copied with normal cp command. You have to use special option for the ls command and cp command to move or copy or to list these files starting with dot. Exception is the root directory, which is always forward slash. Root directory means the top level directory. So top level directory is the root. Under root we have different directories and files. No other file can use this name. I'm talking about the root directory name. So other than root, you can keep any file, any name to any file. And good thing is that as a convention, not as a rule, because rules are slightly different. Convention is that don't use uppercase names in files to whatever extent possible. Convention is that don't use special characters in file name, like star should not be used in file name, comma should not be used in file name, semicolon should not be used in file names. So special characters should be avoided as far as possible, because if you use, though you can use special characters, but that will create problem for you later on in your own understanding, because you have to use double quote in order to enclose those special names, special file names which have additional characters, special characters in them. Now other file name rules. Other characters may be used by escaping them. As I said, you can use special character, but you need to escape them. So for example, Willy whistle. Now you see here slash star. So slash star basically here refer to I want to include star in the file name. So actually the file name will be Willy star whistle. This is one file name. So here we are using star within the file name, which is not encouraged and not recommended. Alright, because every time this will confuse you whether how should I read this file name. You cannot specify cp Willy star whistle. Every time you have to use while referring to the star you have to use slash. So it will confuse you that why I'm not able to read the file name, why I'm not able to name the file, because every time you may not be able to remember that I should use slash star in order to use this file name in any command, cat command, ls command, cp command, mp command, vi editor, editing the file. Wherever you want to name this file you have to use slash star, which will be very difficult for you to remember. That is the reason I suggest that don't use these special characters in your file name. So much confusion can result from this kind of naming convention if you want to use them. Though you can use them. We already discussed that file names are case sensitive. Small case, uppercase, all these are unique names for Linux. Absolute path name we discussed, I demonstrated in the previous session. Every file has a path name. A path name is what? It is built by tracing a path from root directory through all intermediate directories to the file. String all file names in the path together, separating them with slash and proceeding them with the root directory. Repeat in between. If slash appears, then this is just a separator, but if it is in the beginning, then this slash is called root. So for example, in this case this is root, this is a special, but in this slash and this slash, they are just a separator, path separator. This is just a separator here, this is just a separator here, this is just a separator here, but this is a special case if it is in the beginning. In the beginning, slash refer to the root directory. If this slash appears anywhere else, then this is simply a separator. Please take note of this point. This is important point. Now path name, let's take a look at. This is a root directory as I see right in the top. Under that, what you see is we have home directory, we have temp directory, we have etc directory. So what will be the path name for this file? If this is a directory, sorry, what will be the path name of this directory? it will be slash etc, because this directory is directly under slash directory, so it will be slash etc. Same way, what about the home path name of this? It will be slash home, because it's directly under slash, so slash home. What is the path name for this directory? Okay, so path name will be slash home slash hls. Why? Because this directory is under home and home is under slash, so we start from slash home slash hls. Same way, bin log. So what will be the complete path of this directory? Log is under bin is under hls is under home is under root, so it will start from slash home, oh sorry, slash home slash hls slash bin slash log. Same way, nodes. What is the path name of this directory? So it will be nodes is under hls is under home is under slash, so it will be slash home slash hls slash nodes. Exactly same way you can look at the other paths also. So this is how the paths are represented, like path of this file. So starting from here, so it starts from here, it goes up to here, from here to here, and finally this is the path. So you have to use all the intermediate directories which come on the way to reach to the directory, right from root directory. So that's how you define the absolute path name, right from slash. So a relative path name will be relative to the current directory where you are working right now, because you cannot be present everywhere. You have to have one working directory at a time. You may be working in this directory or in this directory or this directory. Remember, directories are working directories. You cannot work in a file. Files are worked on, not in. Directories are you work in directory, and when you say work file, you work on files. So working in a directory, you can go to any directory, you can make any directory as your present directory or present working directory, and the pwd command gives that present working directory. A relative path name. Every directory has two intrinsic directories. Intrinsics, that is default. One is dot, which represents the current directory, and dot dot, which represent the parent directory. So parent means top level, just above this directory, under which directory this directory was created. This makes using a relative path names comparatively easy. Node, inode or inodes. Inode contain information about the file. It is actually the real name of any file. Every file is identified internally by inode number, and every inode table, in fact the files are managed in the inode table, and the inode table is a table which consists of the list of files and directories on the system. So what are the typical entries in the inode? Any inode or any record. Inode is basically a record, as I said. So any inode consists of these records. For example, owner name. In this case, for example, Sangwan. Sangwan is the owner of this file. Then group ID. So who is the group ID? What is the group ID of this file? What type of file it is? Regular file. What are the permissions? What last access, last modified, size, number of links, disk address. So all these records are part of inode entry. What is inode? Let me explain once more. Inode is basically internal record of a file. The record contains many information about the file, like owner, group, type of file, permissions, last access, last modified, size. Alright, and that record is identified by a number or index number or inode number. Inode number do not store the path or file name information. Alright, they just store the details about the file, not the path about the file. This is inode. Internally, all the files are identified by this number or inode number. In the ls command, you can use -i to display the inode number. Okay, link. First of all, we need to understand the need. Why do we need the links? It is a useful concept. It helps us to great extent in certain situations. Let me take example. I want to configure web server, FTP server and NFS server for my installation of Linux. Web server, FTP server, NFS server for my Linux installation. So what I will do is I'll copy the contents of the DVD, ISO DVD at one place. Each of these servers which I just talked about, FTP, HTTPD and NFS, physically they are mapped to different directories. Now if I want to make my operating system available through all of them, I have to keep multiple copies of the operating system, and it is nearly 4 GB, so I will be wasting around 12 GB of space, and that does not make sense at all. What is the right approach is I copy the data at one place and then create links to that place from every other location wherever I want the data to be visible. That is called the link, symbolic link. In Windows, if you have worked on, we have a concept of short link or shortcut. Shortcuts are just link created on the desktop or wherever you are, which actually point to the real file or real location of the file. So therefore link command or ln command create pseudonym for an existing file, a symbolic link to the existing file. Syntax is ln, that is link, hyphen f means force, hyphen s means soft link, file name, that is the source file to which you want to create, and link name, the actual link where you want to create the link name, the shortcut name. So hyphen f, hyphen s. Hard links are default. They create a pointer to the file. Symbolic link or soft link create an indirect pointer to the file via path name. Alright. Although only the super user can create a hard link to a directory, any user can create a soft link. And soft link also work across the file system, and therefore they are a preferred choice by any user. Let's create some symbolic links and hard links and understand the real difference between the two. What is the hard link and what is the symbolic link? That will be of great help, so that once you understand, you will have a good idea about the hard link and soft link. So let me demonstrate this. So here we are. You see my system, ls command, ls-l. So we have a lot of files and directories here. So let me first remove them. So many of them are there, so I don't need all of them. Test. Now we have quite few of them, ls-l. Alright, now let's create a symbolic link to this file, world.sql. Alright, so the command will be ln-s create symbolic link to which file? To this file. Alright, this is the original file. Where I want to create the symbolic link, I can create it anywhere, but let me create right now here only. So world, WORLD, and let me give a name, let's say LN, world link. This is the name. Now when you use ls-l, you see that this is a pointer and pointing to world file, right? Now if I use ls-i, alright, and I'll see the inode number. What is the inode number of this file? This is the inode number. Inode number of the link is 9454, and inode number of the original file is 2530. So we have two different inode numbers. That means we have two different entries. So if I remove the original file, what will happen? Remove world.sql. I remove this. Now what will happen if I try the same thing command? It will start blinking. What does it mean? It says that, boss, you have a pointer to something which does not exist. We call such pointer as dangling pointer, because now the destination file does not exist and we still have the pointer to that file. If I create the file such world.sql, alright, then you will still have the link working properly. Now the link will come back. It really does not matter what was the content of the file, whether this file is same file or different file. Only the name should be the same. All right. So that's how you can create symbolic link or soft link. Remember, in soft link we have inode number are different. Now we'll create a hard link. We'll create a hard link now. ln ls-s. This time we'll create a hard link for the passwd file. Now let's first take a look at the content of passwd file. These are the content. Yes, okay. Yes, I can explain it, but let me complete the hard link so that I can differentiate the two, and then more examples will help you understand. ln-s. Now I have the passwd file. I create the hard link for this file. So ln without any source or without anything, I mean no option. So the file name is passwd, the passwd file, and the hard link I create a new passwd or new pass. Alright, PASSWD. Alright, now ln-s ls-il. The important point is now refer to this file, pass, new pass, and the passwd. So this is the passwd file. Look at the inode number. They are the same inode number. Same inode number meaning is what? If you delete one entry, you still can access the data from the other inode number. So which means if I remove the file, new original file PASSWD, I can still access the data with a new name. So I can still work with cat new pass, and I can still access the data. Now it is a time to understand the difference between the two. ls-il. Difference between the two is when you create soft link, you create a pointer to the file, pointer to the directory. Alright. When you create a hard link, inode number remain the same. You just create as another entry with the same inode number. In case of hard link, you can access the data if the original file is deleted, original directory is deleted. Why? Because there are two entries with the same name. So if you delete one entry, it is okay, and you will be able to access the data from the second entry, that is hard link. In case of soft link, it is just a pointer. So if you remove the original file or original data, you will not be able to access the data, because pointer is pointing to something which does not exist. In terms of inode, take note of it that soft link create separate inode numbers, separate entries, separate inode numbers. But whereas in hard link, inode number remains the same. So links are important. When you will be working as an administrator, you will be creating a lot of links. Like if I use ln ls-l and /run directory. If I see /run, in my opinion, that is a pointer to some other directory. Oh, I should not have specified the directory /run/. Oh, 1 second. Let me specify simple slash. Now this is what I was talking about. Look at this root directory content. There are so many symbolic links. So actually when you go to lib directory, when you do cd/lib, you actually go to this directory. When you use lib64, you actually go to this link. They are soft links. These two links are soft links. So sbin is a symbolic link to user sbin. Bin is a symbolic link to user bin. So when you type cd/bin, I type cd/bin. So I actually, if I try pwd, I'm working under /bin, but I'm not working. I'm basically working in this user bin directory, because this bin directory is pointing to slash bin directory. Alright, so that is concept of symbolic link, and they are quite useful because same data, same directory, if you want to be available at multiple locations, what you do is you create symbolic links to that place, to everywhere wherever you want the data to be available, and that's a quite useful concept. Now if you have any question, please let me know. Okay, so concept of link is basically they are pseudonym, they are another name, they are shortcuts. If you have used Windows system on desktop, you see so many names. These actually they are not the real files, they are pointers to some physical location. So links are pointers which point to the file, and they are useful because you cannot be you cannot present one file at multiple location. That will waste you a lot of space. So to save space wastage, you create links, because you simply create a link to that file where you want them to appear, where you want that file to be visible. So that link will help you to reach out to that file from anywhere, and they are quite useful. That's what I can explain right now, because once you create, once you use them, you will find them, yes, they are useful. It is presence of a file at multiple location is done using soft link. If you do a copy of the same file at different location, you will be wasting a lot of space. To save that space and still make the concept of visible, still make this concept appear, you can use this. So why do you need hard link and soft link? Probably this concept will help you to understand. This slide will help you in understanding this. So why do we need it? Hard links all have equal status. When a file with hard link is deleted, the actual file remains until all the hard links have been deleted. Why? Because you know that inode number of hard link is same. Ultimately, as I said, the files are identified by inode numbers. So therefore, if you remove one link, one inode entry, you have still another entry to refer to the data, because ultimate data is identified or accessed by use of inode table, inode record. And since you have the one inode entry available after the deletion of another, you still can access the data. So this point is very important. When a file with hard link is deleted, actual file remains until all the hard links have been deleted. That means you can still access the data. But in soft link, that is not possible. Soft link can have original file deleted while soft link still remains, but this link will not be able to access the data because the original file have been deleted. So this, once the file is deleted, this pointer will become null pointer or dangling pointer. The dangling pointer means it is pointing to something which is not there. Soft link can also be confusing when used to change directory. Suppose you have a soft link called my directory that points to your home directory /home/krf, and you use cd my directory. Then if you use execute pwd, it will show home krf. Pwd shows the name of the link to do directory rather than the name of the link. So that is how soft link works, and why do we need the soft link. Why not just CP? Why do you need link? That is the point which I told you, that if you use CP, you can use that. You can copy one file at as many locations as you want. That is right. But then problem would be, a lot of problems will occur. Like if you want to make change to the file, you have to copy it again everywhere. And you will be wasting space, plus any update, you have to replicate the CP command every time. So in case of it creates a pseudonym for given file, no new inode is created, only one copy of the actual file exists, Modifications via either file name affect the original file. CP create a new copy of the given file. A new inode is created. Twice as much of the disk space is used, and modifications to the copy are not reflected in the original. Now you decide whether the CP or inode, CP or link, in order to have multiple copies of the same file. Which one is good? Call is yours. More command, it is a pager, we have been using it. So more command is quite simple, page through the text file, because if simply use cat command and file has a lot of data, then it will simply scroll through and you will see only the last full screen of the data of the file. More command helps you navigate through the file line by line, one full screen. Then you continue pressing enter key and you can navigate through the text data. So it is pager. You right word is pager actually. So syntax is more followed by the options followed by the file name. So the options are -C. If you use C, that means clear the screen before displaying the text. -D, display error message rather than ring bell if an illegal command is used. F, do not fold long lines. L, do not treat form feed character as page breaks. S, squeeze multiple adjacent blank line into one and suppress underlying escape sequence. Let me tell you very frankly, I never used any of these options, and simple more command is good enough for us. So we simply use cat file name piping symbol more. This is the most frequently used sequence, or simple more followed by the file name. So more is generally used with piping symbol rather than independent command. So options, when the file is open with the more command, do we have some options available within the screen when the file is still open? Yes. Like for example, if you simply type I followed by the space bar key, that means display another screen or I more lines. Like if you type 5, it will display 5 more lines. I followed by return, display another line or I more lines. V, drop into VI editor at the current line. Let's try it. These options seems to be good, but I never use them, by the way. I want to use them, I want to try them in front of you. Here we are. So let me see a file. I would like to open the file names. So in fact names is a very small file. Let me start with more followed by passwd. What was the file name? New passwd. Yeah, right, new pass. Alright, so now you see 33% of the file is open. Okay, and I want to display 5 more lines, so I simply type 5 space. So I type 5 space and you look at it from 33% to 42% jump. But if I press enter key, it will open one line at a time. Right, you look at the last line is RTKIT. Now I'm going to type 3I, and then we'll remember I mean simply 3 followed by enter key. So RTKit is the last line. I type 3. Alright, I press the enter key, it took me out. Let me do it again. So I type let's say 2 space bar, and you see after that 2 space bar it displayed me 2 lines. Now I type another 4 followed by space bar, and I type this. So the moment I'm typing, let's say 1 space bar and 2 space bar, 4 space bar, I'm seeing the line, number of lines one by one, 4 lines at a time. This time I press 4. So USBMUXD is the last line, and I type let's say 2 space bar. You see 2 extra lines are displayed. These 2 lines are displayed. Now I type 5 space bar. Now you see after that 5 lines are displayed. 1, 2, 3, 4, 5. And if I type V, simple V here, it has opened the file into VI editor, and now I start editing the file. That is a great help. I can still start editing the file at this point only. So, but I never use them. They are so powerful, so useful. Sometimes also I also learn while teaching that I should have been using this feature, that jumping to line or editing the file at that very moment. So this is open in VI editor. Since we have not done, and once you are saved back, you are back into the more command. That's a great thing. So you can edit the line. You can come back to that file again after you quit the VI editor. Of course, we have not done the VI editor so far. Once you do it, you will understand it. That VI editor is a great editor for Linux, and we use it frequently. So this is very interesting. I just use it and I found it very easy, very interesting. VI also I tried. This also this is basically searching. Search for ith occurrence of a pattern. Hyphen help. Dot repeat the last command. So these are the commands which can be used with more command. You need to practice these commands. I tried 2-3 commands. Word count. I have demonstrated this command earlier. WC is word count. In fact, it can count word, lines, characters. So you simply type WC. After that you type file name. It will display lines, word and character all. But if you want only the lines, you type WC-L followed by the line file name. If you want only the words, you type -W, WC-W file name. If you want only the characters, you type -C, WC-C file name. Alright, look at this example, WC test file. So it will say 7 lines, 43 words and 168 characters. That's how it is. Quite simple, so I'm going to demonstrate this. History, we have done the simplest part of the history, but we'll do more examples in this session, in this command here now. History is whatever command you have used. You want to see the list of the commands you issued. And if you want to issue the previous command, previously issued command, there are a lot of shortcuts available in the history. Display the history list in bash, C or corn shell. Syntax, history -H-R or N. H means display history without line numbers or leading numbers, which always are displayed by default. R, display the history list in reverse order with most recent command first. -N, number of previous commands to display, like if you want to display last 5 commands. By default, bash stores the last 1000 commands, but this limit can be changed by using hist size environment variable, which I discussed when I was talking about the environment variable. The hist size variable is defined in one of the login script, like either etc profile or bash rc or .bash rc, which I discussed. I hope you remember the file name. Changing the history, or sorry, using the history always proceed by a semicolon, oh sorry, colon, exclamation mark, I'm sorry. We call it as bang. This identifies the command as a history command. So like if you type double exclamation mark, repeat the previous command. Exclamation mark followed by N, repeat command number N. Right? So then exclamation mark minus N. N is the number here. Repeat nth to last command. Exclamation mark str. Repeat the command beginning with str. Let's try actually. This is worth trying. So here we are. Let's use ls history command to see the history first. Now, if you look at a lot of commands are there with their line numbers. That we last used the history command. Before that we use clear command. Before that we use more new password command. These are the commands. Now, if I want to issue the previous command again, I can type double exclamation mark. Alright. If I want to issue line number with the given number, I can use this command followed by the number. So for example, I can use this command. Let's say I want to use which, okay, 704, exclamation mark 704. This will use the command more new pass. So look at this. Same way, if I try history again, and I see the line beginning with something, okay, with cat command. I want to start the line, whatever command, most recently used command that begin with cat, I want to issue that. So I type exclamation mark cat. This will issue the most recently command which start with cat, and that command is here, line number there. So cat new pass will be used. So enter, and look at this, new cat command followed by new pass commands are used. So these are the techniques you need to practice these commands that history command offers a lot of things. So this is how you can search. You can even search like a question mark star str question mark means containing str. Like if you have something very interesting in between the command and you want to execute that command which have something text of your choice somewhere appearing in the command itself. So you can use exclamation mark, question mark, the string, question mark, and that's it. So, and this is the using history command examples. A lot of examples are there. Let's take example now from here also. More examples. Like if you type history and these are the command who, wc, cal, emacs, calendar, emacs, datebook. Now exclamation mark w means the recent line which starts with w will be executed. And which one is this? Starting from bottom. So wc-l data, this will be executed, and that's true. If you type exclamation mark wh, so which command start with wh? Who. So this will be executed. Exclamation mark, question mark, datebook. Which command start have datebook in it? Emac datebook. So this command will be executed. So that's how history works. Command editing. Like let's try to edit the command history, and you have these two commands suppose. Now you can substitute the word in the command and followed by the substitute in the option like. Okay, so in command number 350, exclamation mark 350, that means I am talking about this command. Colon s means substitute. Substitute what? Substitute calendar with datebook. Substitute calendar with datebook. The command will become emacs datebook. Emacs datebook. This is how substitute works. This command, same thing can be achieved with caret symbol datebook, caret symbol calendar. So that will also work. So basically a lot of tricks are available with history command to make your life easy while issuing a given command. File command. File command is the last command which will determine the type of a file by examining its contents. Like it will look at the contents, it will see what type of content file has, and it will display that. Let's take a look at this command also before we proceed. File command is sometimes useful because you don't know what type of file it is. So file command will help you in understanding that. So let's type file followed by, let's say, down desktop. File desktop. So what it is? It is a directory. Desktop is a directory. Now again file followed by, let's say, local.te. So it will say is it ASCII text file. Let's try again. A file, this time with this SQL.zip. So it is a zip archive data, at least version 2 to extract. So this way you can specify, find out what type of file it is, like file /dev/sba2. So it is a block special file. So this way you can find out the type of file, what type of file it is using the file command, and that is very helpful for us while we are working on Linux. So file command will tell you what type of file it is. sometimes we need this information. That's all for this session. I hope you enjoyed it. Thank you very much for watching.